The DT6 uses powerful chip-based triaxial accelerometers that capture the full range of all three channels. Simply place a sensor on each bearing, being sure that the top ridge is facing up, and you're ready to take a reading. Just tell the software where you put the sensors and you're ready to take 6 channels of complete, powerful, phase synchronized data. To take a reading, you go to the Acquire panel. This is a top-down view of your unit train. The red marks indicate possible measurement points. In this case, we have the green sensor and the blue sensor in the horizontal position of the drive or motor. We could place it on the axial, the back, or the vertical positions, but the standard is to do it in the horizontal. You have 2 different inputs. You have the sensors and then a simulator input. We'll use a simulator for speed right now. Simply determine how many seconds you want to take. The more seconds, the higher the resolution. There's no other setup required. There's no Fmin, Fmax, lines of resolution. All of that is handled because the system takes all the raw data, full frequency range, each and every time, and post-processes after that. Much more efficient and easier. So we'll take it on this first unit right here and take a reading. Note that everything turns green, which means everything is there and synchronized. We could either move the sensors like this, or you can even march down the unit train. This control controls the front one. And say put them on the pump, take a set of readings. Now you'll notice that I've got green here and yellow here. Yellow means I have data, but they're not quite adjusted to be in sync with these in a phase sense. So we need to take one more reading, cross the coupling to synchronize the sets, and there you go. Simple rule there on the yellow and green and red. Any yellow to any green, any combination will adjust everything for you. Very easy. Once we've taken a data set, we go to the analysis. Here in the analysis we have the FFT. We can simply scale it, little tools to match scales, easy navigation, putting on harmonics for cursors, putting on windows, changing it from acceleration to velocity to displacement. We can change from imperial to metric units, peak to peak RMS, track cursors, do lots of zooms in, zooms out, bandpass filtering over here. We can also take a look at the time waveform, which is the full duration of the reading. So we can zoom in, look at any particular point, have different cursors to go ahead and tell the period and frequency. We can also put on multiple sets. This is set to where we have the phase calculated to see multiple cycles. A few handy things there. Then we can come over here with statistics, talk about acceleration, velocity, displacement, peak to peak, RMS, crest factor for each individual channel. These, by the way, are completely independent displays. So the top and the bottom, I could be navigating the units up here. So I can be looking at the end unit right here and the data here, or the first unit and the data here to do comparisons. Select which area you want to see the full data set, and when you are in a given point, you'll see all 3 channels plotted. If you want to clean it up just to look at one, you can toggle these on and off. Over here you'll see the phase relationships for you. So everything is already done and nice and easy to navigate and to look at your data. Have one very unique thing here. Since we've gathered all points and we have phase synchronized them, we have some powerful things we can do with phase. Here we have a complete balloon diagram already filled out for you. We see the phase relationships. Now, as we go through the process of doing phase analysis, we want to know what is the relationship or the phase difference, vertical to vertical, horizontal to horizontal, or end to end, vertical to horizontal at one given point or bearing, cross the coupling, axial, etc. We also want to know about what are the amplitudes in these various places. all this data is there, but it's nice just to jump to the summary, where what we've done is we added a point system that if things are completely lined up perfectly, you get more points than if it's getting a little bit off in phase until you get no points because it doesn't indicate that point. Then we summize it here for imbalance symptoms, misalignment systems. Your eye quickly catches where the strongest symptoms are, but again, it's much nicer and easier just to run down to the grand total, and this is over here indicating that this machine is misaligned. Over here we have resonance indicators. Of course, resonance affects phase, so we don't have it calculated into this total, but we do look for unusual phase angles at a given position or highly unusual amplitudes, things of that nature, to help bring your eye to look for bent shaft and resonance issues. Then over here, we can go ahead and now visualize it. This is an animation that tells how the actual data is moving, and these are your two shafts as to how they're moving relative to each other. Another way to view it is to look at it in this other 3D angle. We can look at it in various angles, but fundamentally we see that the two shafts in this case are moving in a very directional flat orbit view, and this flat orbit where you're going either up and down like this is a very strong indication that it is misaligned. If it was out of balance, this orbit would be nice and equal circular. What comes around goes around is the saying. So you either have this kind of a pattern showing misalignment or a nice round pattern showing imbalance. You've got little controls here because the amount of amplitude and the speed will vary, so we can amplify the motion, we can change the speed, shift and zoom, and do various things to get a really good visualization. Here are those phase plots again, or the orbits again. Nice angular flat orbits. This thing is misaligned. One last thing to note is that you can create pictures of any given zoom level of any plot at any time by hitting the Create Picture button. It'll put it into a directory that you can then drag into a Word document or something else to help create a report. And then lastly, we have what is called a phase cursor. And if we zoom in on this phase cursor, you'll see that it's a yellow dotted line. We can change this cursor to any given frequency, the 2 times whatever, most often it's the 1 times RPM, and it will calculate the whole system phases and look at all the relationships, animations, etc. based on that new frequency. So it's quite powerful as a multi-phase or multi-frequency phase calculation. The Pro version adds a few more features, and one important aspect is this asset database. In the database, you'll see it's a standard tree control. Over here, these will dynamically change for what level you're at. Green is add, edit blue, delete red. So it's fairly intuitive and straightforward. We can come on down to a generic unit train, and then all the associated DT6 complete readings are saved over here. We can go further in for adding positions and measurement points, etc. Another nice thing is it's very fast and easy to go ahead and set up a route. You can either go to an existing one and modify it, or let's add a new one very quickly. Here's a new test route, and give it a description. And now all you need to do is navigate on down, and you can either add individual measurement points, or we can just simply go to the full unit and add them all. So I'm going to take the unit 1, the unit 2, commit the changes, exit. Now we can exit out of the asset database, and it's that fast to create a route. We'll go ahead and clear our previous reading, go to the acquisition panel, where we can select a route. Hit the route button, grab the new one we just created. Below it, we can now select from the unit trains we put on that route. We grab this one, hit OK. It'll populate that so that when we go ahead and take a new set of readings, synchronize it. Once we're done with the full set, we hit accept, and that'll put it back into the database, move on to the next unit in the route, and continue on through. When we want to take a look at the database, we can go back here, Asset Database, navigate on down, and that's our previous reading that we just took on the route. Open the file, do the analysis, go from there. As you can see, the DT6 is an extremely powerful and versatile instrument that does an awful lot of things that no one else does, and provides the important information of phase that is so often missing yet is critical to fundamental analysis. For more information, please contact Update and we will get more information to you. Thank you.